Hello students, today's class will start off with the numericals. This first numerical. Yesterday's class we covered introduction, then we started the introductory class, then we went on to see the procedure on how to solve the numericals on helical gears, right? So this first numerical is very basic, I can say very elementary. Um This is all the data as is given. Check out the question. A pair of parallel helical gears consisting of 20 teeth on pinion, meshing with 40 teeth in gear, helix angle 25, and normal pressure angle 20. The normal module is 3 mm. So module everything is given to. So you don't need to find anything, and what you need to calculate is given already over here. So these kind of problems, no, they are just uh, like for 5 marks. They are 5 marks questions. So that's how it is. Will be given. So 1 mark for each. Sorry, we didn't solve this thing in particular when it came to the procedure. So let's see how we can solve this. So I hope you have a screenshot of this question, and let's note down on a parallel sense how to solve this. Okay, so I hope everyone is able to see what I'm sharing. So pair of parallel teeth consists of 20 teeth on pinion. Let's start this. Right. So given is number of teeth on pinion. Pinion is Z1. So Z1 is a subscript for pinion, or you can subscribe it as ZP also. Right. So similarly, number of teeth on the gear. So gear will be denoted as Z2. Z2, or you can subscript as ZG. That also works. And what else is given? Number of teeth. Then helix angle 25 degree. 25 degrees on helix angle. Yeah, for helix angle, we'll just use the notation beta. Beta might be somewhere. Okay, some students are still using the old link. Can someone reply in the group? Use the updated link. So this is beta. We use the symbol beta for use a simple beta for the helix angle. You can see here helix angle 25 degree. This is 25 degrees, and normal pressure angle. You can see in the question, the normal pressure angle is 20 degrees. So this is the form of teeth. This is a form of teeth. Form of teeth. You can see that it is 20 degrees. So this is alpha. So don't confuse between the helix angle and the normal pressure angle. So 20, 20, 14 and a half. These two are the form of teeth. Okay. So any other than these angles, if it is given, then you need to use the form. There is a normal pressure angle. Okay, let's calculate these values here. Oh, and module also is given. So m equals 3. Right. So we need to calculate transverse module. These are given in page 211. We check out page 211. You can find everything is in the same page. Okay. So all everything are in the same page. You can take a screenshot of this also. So that is just a plug and play kind of a question. Okay. Let's see. Let's see a solution. So first off, you are finding the transverse module. Okay, check out here, transverse module. Normal pitch. Oh yeah, transverse module is nothing but the normal module. Normal module given by this formula here. Okay, mn equals m cos m times cos beta. Okay. You can use that mn equals m cos beta. Okay, so we can calculate this. So this is just 3 times the module and cos of beta is 25 degrees. The solvent posted in the group. Those who are in. This is the first thing, transverse module. Let's say transverse module. Okay, so this is the first one. Second one, transverse pressure angle. The transverse pressure angle, you can see here the relation between normal and the pressure angle is transverse plane. Okay, so transverse plane is given as alpha. Alpha times cos beta. Alpha n is the normal plane. What is being asked is transverse pressure angle. The transverse pressure angle. Using transverse pressure angle is alpha. I think alpha is already there in our question. This 20 degree. Okay, using. We can just find this alpha n. This is the normal pressure angle. These are just normal and transverse. Because transverse module, this is the normal module given. We need to find the transverse module. So normal module. Let's go back. How is the normal module? It is given. Oh, okay. So that means this is not our normal module, right? All right. This is not our normal module. This is our normal module. Normal module. That means we need to find m here, not not the other way around. So this is 3 equal to m cos 25. So that means m will be then this, it makes it this as normal mn. Normal module you designate as mn. Okay, slight correction. The normal module mn, okay, mn is 3, but we are required to find the normal module. What is given in the question? A normal module is given, so we are finding the transverse, not normal. The normal module formula is this, and this is the transverse module. You can post it in the group what the value of m is. So next one, transverse pressure angle. So here he is giving the helix angle and normal pressure angle. That means this is the normal pressure angle, alpha n. You need to be careful while reading the question. Normal means you give a subscript as n. The normal subscript you give it as an n, and transverse is just without the n, right? Okay. So next thing, transverse pressure angle. You can see it in the next slide. Transverse pressure angle is this here, this alpha, small alpha here. So we'll use this formula. So tan of alpha n. This is the formula for right, equal to tan alpha and cos beta. So tan alpha is known. Tan alpha n is 20 degree. Okay, so this equal to find tan alpha times cos of beta, that is 25 degrees as given in the question. Now here we need to find what is alpha, that is the transverse pressure angle. So you can calculate and post in the group chat for everyone to see. Anybody done with the transverse module? Okay, so in this problem you'll come to know the distinctions. The alpha and what is given in the question. Normal, we'll go back to the question. See, transverse module, you need to find these. Normal module is given. So that is m, and you need to designate as m subscript n. Similarly, normal pressure angle is given. Normal pressure angle means this is the pressure angle for the formative gear or the virtual gear. So that means you need to designate this also as alpha n. So thereby you need to reduce these values before we go into the actual problem. That's why this numerical is easy and given as a prerequisite, so that you can know what is the difference between normal pressure angle and the transverse. Normal always means that it is for the virtual gear, right? Okay. So any solution? Let's calculate this. This is 3 over cos 25. Somewhere around 3.31, and the pressure angle is 3 tan 20 over cos 25. This is around and tan inverse of this answer. So this is coming around 21.88 degrees. Right? So this is how we calculate the transverse values. I hope you have got the same answers. let me know if I'm wrong. Right, let's move on. So transverse module is done, transverse pressure angle is done. Next is the axial pitch. So for the axial pitch, let's go back to the data handbook. Axial pitch, the normal pitch and diametral pitch. So we have two values here. The normal means it is for the formative gear. So axial means you find this diametral pitch. Okay. Okay. Again, whatever is normal here, it means it is for the formative gear or the spur gear, the virtual spur gear which we talked about. So we'll find for the diametral pitch this PD. What we know here is we can use either of these two formulas. So this is 1 over m or cos beta over mn. So we have both data, so we can just use it. So PD. So this is for axial pitch is the diameter. This is the diameter. Okay, so this is P subscript for D. Diametral pitch. So this you can write it as just 1 over m. We have both data, so you can just substitute that. So this is 1 over 3.31. So what does this give us? 3.3. 302. That's the axial pitch. Okay, so from the formula ED 1 over m, right? Then next value, next thing what we need to find, pitch circle diameter of the pinion and gear. Pitch circle dia of pinion and gear. So pitch circle dia given here, this formula. Okay, so pitch circle dia is D. This will be for separately written for pinion and gear. So let's say pitch circle dia for pinion equal to, we'll designate this as D1. Remember, one is for the pinion, or you can designate as DP also. So this is Z over PD. So Z is the number of teeth, so we have the number of teeth. Just give a fraction. This is Z1. Z1 over PD. Okay, so this means it is, we know the value of Z1, that is 20 number of teeth, but PD 0.302. This in a similar way we'll define for pinion the gear also. In a similar way define for the gear. That means all will be designated as 2. So this will be 40. Okay, so calculate this. Tell me the values if you have found out. So that is for pitch circle diameter. And finally, what is asked is go back to the slide. The center distance. Center distance is just summation of the pitch circle radii. Pitch circle radii of both the pinion and gear. So center distances is nothing but R1 plus R2. It is just R1 and R2. Okay, so before that, we need the diameters. Let's find the diameters. So this is 20 over 0.302 is around 66.245 mm, and for the gear is 40, around 132.45 mm. So half of both is divided by 2 plus 0.225 by 2 is around 99.34. So that's how you find the center distance. This is how you take radii of pinion and gear and add them up. So that's how you do it. So that's it for the first numerical. So any doubts in here, you can post in the group. So this numerical mainly done so that you can know the difference. What is the normal and what is the transverse? Okay, normal module and the transverse module. Normal and transverse. Two things you have to know. So normal always means it is for the formative gear, formative or virtual gear. So normal equal to virtual or formative gear. Okay, so all three they mean the same. Virtual gear, formative gear. So these are different terms should be used in the questions to follow. Okay, so this is that's it for the first problem. Note down the second one, or take a screenshot of the second numerical. So this is the actual problem. This is the actual exam problem or test. This is how it will be given in the tests, the numerical. So note that some data might be changed. Instead of directly giving you helical gear, we may give you a gear which has to operate very silently, or some other data related to a gear which is fully submerged. Okay, those kind of data. If you see those data, you have to directly come to know it is a helical gear. Okay, so spur gear and helical gear will be confused most of the times. So you need to read the question carefully and then solve. So in this, it is given directly. So in tests and exams, don't expect it will be given directly. Read some theory related to the helical gear, and then we can proceed. Helical gear, so that you know which type of gear is given in the question. Right. Okay, check this question out. So design a pair of helical gear transmitting 12 kilowatt, 1200 RPM or pinion, and velocity ratio 3. Pinion number of teeth is given, and is made of carbon steel untreated. The gear is made of cast steel. So two different materials are given, and teeth are 14.5-degree involute form, and helix angle is given. So yeah, this is one more thing which we can use. If helix angle is given, you'll know it is a helical gear. Okay, so this is one more hack we can use so that to identify which type of gear it is. If it is not given the first line itself, okay, helix angle is given, it is a helical gear. You know that the rest of the question is very similar to spur gear. Okay, it's very similar to spur gear. So let's start off with the no problem. Right. So what is given is say power is given 12 kilowatt. Let's say power is 12 kilowatt. Then RPM of pinion is given. So RPM of pinion, N, will use small one, N1. So 1 is for pinion, or you can use NP also. Okay, that also works. You can designate it as NP or N1. So both can be written as the same thing. Okay, NP or N1. This equals to 1200 RPM. Then velocity ratio is given. Velocity ratio means it is you can write it as this N1, N1 over N2. Okay, N1 over N2. This equals to 3 by 1. Or just you can write 3. This is the velocity ratio. Then what else? Number of teeth. The material is given, and number of teeth on pinion is given. ZP or Z1. You can write Z1 is number of teeth on pinion, Z1, and designate this. This is equal to 24. Okay. It is made of carbon steel. So pinion material. Pinion is made of carbon steel. 0.4%. Right. 0.4% carbon steel untreated. And gear is made of cast steel. It is a just cast steel. And teeth are 14.5 degree involute form in normal plane. So it is given in normal plane. Therefore, you need to write alpha and n. Designate this as n. Alpha n is given. It's in a normal plane. You need to note carefully. This is 14.5 degrees in the normal plane. Then finally, helix angle is 25. So this you can designate beta. Helix angle is 25 degrees. Right. So this is all the data which is given. Okay. So sometimes this question may be twisted a little bit, like giving all this data. You can just ask you what all could be found. Okay, what all could be found? Write one by one. Okay. So in that case, you need to write the steps itself. So steps itself will fetch us the answer. So step 1, you need to find the weaker member. Step 2, find the module using tangential tooth load equation. Then step 3, you need to calculate the gear tooth parameters like dimensions and all. And step 4, dynamic load. And step 5, limiting load. And thus you can find the Brinell hardness number. So all these things, only the steps you need to deliberate a little bit, delineate, write it a little bit on the answer sheet. So read the question. Don't start off blind. So one such question was given in the test 1. You remember, for the springs. Right. So let's go for the solution. So step 1 is we need to find the weaker member. Identify the weaker member. Okay, that's the first step. That is step 1. So since there are 2 different materials given in this question, so we have to find. So if the allowable stress is same, in that case we can decide that pinion is weaker. So let's go back to the presentation and see whether the allowable stress is same or not. Right. So this is our table for taking the allowable stress. We need to take the allowable stress as sigma d from page 234. So let's see what is given. C40 steel untreated. Yeah. So it is carbon steel 0.4% untreated. So it is steel C40. C40 means 0.4% carbon only, untreated. We can use this here. Okay, untreated steel is 207 meganewton per meter square, nothing but Newton per mm square. We'll note this down. This is 207. So for pinion, allowable stress. Let's say allowable stress. Allowable stress for pinion is equal to sigma d1. One is pinion, right? Sigma d1 equal to 207 Newton per mm square. Okay. Next, so the same thing is copy paste. Now this time it is for the gear. This is allowable stress for gear, and designate this as sigma d2. So let's go back to the PPT. So the material was cast steel. Do we have cast steel? Oh yeah, we have cast steel here. There are two grades, untreated and heat treated. Right. So this was not given. This is not given in the question whether it was treated or untreated. So let's take untreated. See what happens. Untreated is 138.3. You are free to choose between these two because specifically it is not given treated or untreated. So you can choose either of these two values. I'll take 138.3. So this is 138.3 Newton per mm square. Right. So undecided still. So that means we need to find the form factor. Go back to the steps. So we need to find y. So this y is to be found. Okay, so this is where we get the y from. We have 20-degree involute system. The alpha value is 20. So we'll use this. So 20-degree involute. It's not given whether it's a stub. So we'll just use the usual form for this. So y1. I have it somewhere. Yeah, the same formula which I have. Okay. So next is this thing. So from the PPT, I've chosen this formula here for 20-degree. Okay. So this is 0.154 minus 0.9. So this is generalized. So I need to condense it for pinion and gear respectively. This is for 20-degree full depth involute system. Let me copy this. And this is for, I'll designate as y1. One is for the pinion and also z1. The number of teeth on pinion is known, but for gear it is not known. So that means we need to find z2. Z1 I think is given in the question. Yeah, 24 is given. This is given in the question, that is how much? 24. 24 is given. You calculate this by the time. I'll see what I can do for Z1. We need Z2, right? So we have the velocity ratio. We can use this. So we can use the velocity ratio here. Okay. So this here is also equal to, I'll just write velocity ratio is equal to this. So instead of N1, I can write Z2 over Z1 is equal to. So that means, so from this we know N1, right? So N2, so N2, that is RPM for the gear is N1, that is 1200 divided by 3. We don't need it at this point, but we'll still keep it. This will be 400 RPM, and now we'll find Z2. So Z2 is 24, that is Z1 into 3. Right? So is 72T. Okay, so anybody found Y1? If Y1 is known, we can find Y2. So designate this Y2, Z2, and this will be 70. Okay, so Y1. 0.912 over 24, 0.154 minus the answer. So we're getting 0.116. Y1. Similarly, for Y2, it is 0.141. Right. So this is 0.141. So still now I think we cannot decide, because you see sigma D1 is 207, Y1 is 0.116, and sigma D2 is 138, and Y2 is 1.141. So we only need to multiply and see whether these values would be correct or not. So let's check it out. The sigma D1 into Y1, whether on what stage it is. Let's copy this. So this is D2 and Y2. Okay. D2 and Y2. Sigma D1 is 207 and Y1 is 0.116. Whether it's coming equal to or is greater than 138.3 into 0.141. 0.141. Okay. How much is this? This is 24.012. What about the other one? This is obviously greater. So you're getting 19.50. So you're getting uh, the value over here as the weaker member, right? Okay, for opinion, check out if my values are correct once again. 0.912 over 24, 0.154 minus this. Yes, this is correct. And 0.12 over 22, 0.154 minus. So yeah, I think we're correct. So we got gear as a weaker member here. Okay, we can write reason since this value here is lesser, we can say gear is the weaker member. Check. Right. So if all values what we have taken is correct, then gear is the weaker member, since we got the value for pinion more than that of the gear. Gear is the weaker member. So the next is design. Design should be based on gear. So whatever dimensions, whatever notations you take henceforth should be in 2. Okay, like Z2, sigma D2, Y2, okay, and so on. Okay. All dimensions should be on basis of gear. Okay, so let's start with step 2. Step 2. What is step 2? Let's go back to PPT. This is step 1, and this is done. Step 2 is we need to find the module M or Mn, okay, whichever the formula suits. Going to calculate this. So let's start off. This tangential tooth load uh, due to power transmission. This is split into 2 parts. So this is A tangential tooth load. This and this is due to power transmission. The formula is this. Okay, let's take this. Just copying this from the previous problem. Right. This is given as 12.78. It's similar to the one which we used in the spur gear. You can see here. Okay. So let's do this. So P is already known. 20, not 12. 12 kilowatt. Then service factor CS. Service factor. Again, for this we need to go back to the presentation. Service factor. The type of load is not given. The type of load here is not given in the question, so we can just assume some value. Okay, let's take 8 to 10 hours per day and no, medium shocks. So 1.5. We can choose here. If not given in the question, we can choose the value 1.5. Note the procedure is important, not the final value. Let's take 1.5. Then velocity v. Velocity v, you need to by heart this formula here. I'll just copy this from the previous numerical. Okay, so here you need to tone it down. So this is not D2, it is not D1, it is D2, and not N1, it is N2, because the design is based on the gear, right? So instead of D2, you can write Z2, and here you write MN. Okay, we're finding the normal module. This is for the spur gear, right? So always designate as MN. This formula is not given in the data handbook, so you need to make this small change here. So don't find M, find MN, because in the next stage you should not get confused. The part 2 of this step now should not get confused. So designate this as MN. This is only for helical. You need to make this accommodation. Okay. Okay. So let's write these values. Let's copy this. So this will be in terms of MN, because that's what we are finding. So Z2, we know what is Z2. That's 72. So 72 into Mn, and we also know N2. N2 is 400. I'll just replace this. This is into 400, and tell me the answer in terms of Mn. You can calculate. Tell me the answer in terms of Mn, and we'll substitute here. This will be first part of our step 2. So this is 1000 into 12, which is P, into 1.5, that is CS. Velocity, anyone? There is pi times 72 into 400 divided by 60,000. Okay, somebody calculating? This is around 1.5. Let me give it as 1.51 times. So this is equal to all of this. It is 1000 to 12 into 1.5. So this is 18,000 over this value here, 1.15 ml. So this will be around, so the fraction is 11920.53 over this ml. Okay, so this is it for the first part. Okay, the second part of this, we'll take it from the Lewis equation. Okay, so part 2 of this is from the Lewis equation, where it is different for helical gas. Okay, I need to type this from the scratch. Let's see, Ft is equal to, we have sigma d times, no, just type it as it is, Cv V capital Y and M. This D is a smaller one, subscript V subscript DYM, N is a subscript, and over C W. W here is where factor, correction factor for where. So this is equation. Go back to the PPT and check it out. Yeah, W capital Y and 12.24 A, 12.24. So among these, lubrication Y is given right below. Y is pi Y. So capital Y equal to pi and small y. This is by default given. So let's find out one by one. This below this, Y equal to pi into Y here is, we need to note Y2. Whatever the value of Y2 is, so this Y2 is 0.141. Y2 equal to again pi into 0.141. This need to be calculated. Then will come from Cv, or will come from sigma d. Sigma d, and subscript 1. This is equal to d1, no, this d2, 138.3. D2 is 138.3. Okay, so these are the we'll stop here. I think we have passed 1 hour duration of this numerical. Okay, so we'll continue from here tomorrow. Part 1 of step 2 is done. So part 2 we are stopping midway. We'll continue in the next class. So any doubts so far, you are free to ask.